Okay, here we go with part 2 of what we began earlier on in trying to determine the dimensions that will maximize the area of the rectangle inscribed within that ellipse. So in order to do that, let's determine a prime at x. So let's go ahead and do that. So a prime at x. Notice that we do have a product. So let's apply the product rule, okay, where we're going to take the first, or the derivative of the first, and multiply it by the second. To that, we're going to add the first term multiplied by the derivative of the second function that's there. So we have the root of 16 minus x squared. Now do recall that that is equivalent to 16 minus x squared to the 1/2. So the derivative of that particular term would then be 1/2 multiplied by the inner function. So we're going to apply the chain rule here to the minus 1/2 and then multiplied by the derivative of the inner function. So we'll find the derivative of minus x squared. So we have minus 2x. Okay. Just move that out of the way. Throw in a closing bracket. Let's tidy things up a little bit here before we move along. So as you can see over here, the second term, these 2's will cancel. Okay, so it looks like we have minus 2x and x in the numerator. So we'll see that's going to be minus. So minus of 2x. And in our denominator, we will see this expression here. So we'll have the root of 16 minus x squared. Okay. Moving forward, what we'll do is we're going to get a hold of a common denominator such that we can bring these two fractions together. So that means that up top here, we're going to need a second radical term of root 16 minus x squared. So all over a particular common denominator. No change to the 2x term. Okay. So when you square a radical, okay, and it happens to be the same one, what that does is effectively, through the operation, we end up communicating the answer without a radical sign. So it would simply be this. Okay, just looking back on my work, I believe we're missing a square in here. There, that'll help matters quite a bit. Okay, so if we go through the top, let's do a little bit of work on this here. We're going to have 32 minus 2x squared minus 2x squared all over the root of 16 minus x squared. And at the end of the day, 32 minus 4x squared over the root of 16 minus x squared. This is a prime at x simplified. So at this point in time, what we need to do is to find some critical values. Let's do that. So our critical values, we're going to set a prime at x to 0 and solve. Now remember that the only way to zero out a rational expression is to simply look at the numerator. So specifically, let's go back to the top here. Where does 0 equal 32 minus 4x squared? Well, we could factor out a 4 while we're on the topic here and get 8 minus x squared. We could divide that 4 out from both sides and be left with this. Last but not least, if we solve this equation, then x is plus or minus the root of 8, which we can express as a mixed radical. Okay, so that's the root of 4 by 2. Split the radical. Square root of 4 is 2. So we have plus or minus 2 root 2. Now, also recall, right, so since the domain was specified as this, we know that minus 2 root 2 is inadmissible, right? So we have to say that this is the case. So now we're at the point in our checklist of all the things we needed to do was to finally determine the dimensions. So recall, okay, so x is not the dimension, but rather x is simply half of that story. So let's go ahead and find out the length, which we had denoted as 2x. So in this case, 2 2s are 4. So 4 root 2 would be the length. And then remember how we had denoted the width as y, which is f at x. So what we need to do is to determine what that value will be. So we want f at 2 root 2. If we go back to the expression we had determined for y, okay, let's take a look. Here's the expression we had determined for y. So let's go ahead and let's evaluate f at 2 root 2. So it would be the root of 16 minus 2 root 2 squared all over 2. When you square a mixed radical, what's going to happen is that the 2 is squared to give you 4. Root 2 is squared, giving you 2. So we end up with 16 minus 8. That full radical divided by 2. So we have a root of 8 over 2. Well, the root of 8 was already written down as 2 root 2. And if we take half of that, we have root 2. So therefore, the dimensions of the rectangle with largest area and inscribed in the ellipse defined by the equation x squared plus 4y squared equals 16 are root 2 by 4 root 2. And that concludes that particular example.